Hello, everybody. I'm Otis Williams, and with me today is Neil Mosquita and Evan Chaya. This is our team. We are made up of energy, electrical, and mechanical engineers. This wide breadth of experience and knowledge allowed us to tackle the many challenges that were presented to us in this project. Working with our sponsor, Bridge Gap Engineering, we were able to communicate with their expertise in the cement industry to assist us on this topic, and the topic being the capture, storage, and utilization of static electricity from pneumatic material conveying. The existing system, to provide a little context, pneumatic material conveying is a popular method of transporting powders through a plant. It uses compressed air to transport the powders, in this case cement powder, from point A to point B efficiently. And the one drawback of this system is it generates quite a bit of static electricity, and for safety, it is typically grounded so as to make sure nobody is shocked by it. So our sponsor, Bridge Gap Engineering, wanted to determine the feasibility of developing a system to capture, store, and utilize this wasted energy to see if it can be used to offset utility lighting costs.
The circuit was designed to only light up the LED once the capacitors have been charged to 7 volts. The 2N7000 N-type MOSFET with the standard rectifier diode and resistor pair regulate the switching voltage, and their values were determined using the National Instruments multi-sim software. For the final circuit, which I put together on a breadboard using through-hole components from DigiKey, I set up our 4 smallest capacitors in series to give us a total capacitance of 25 microfarads, which would allow us to charge up the system rather quickly. The manual single-pole, single-throw switches were implemented to allow more control of the circuit during testing.
The pneumatic conveyor we constructed was able to serve as a proof of concept of our device. It allowed for the air to be transported through a 4-inch diameter tube of PVC at 22 meters per second and was used to transport first cement powder and then sand. Charge builds up on the long 10-foot to 4-inch diameter tube, which is insulated to prevent any of the charge from escaping. A series of metal hose clamps along the tube collect the charge that builds up and puts it into the positive rail of the breadboard. The negative rail of the breadboard is connected to a ground, and through the course of our testing, we were able to capture and store 1.4 volts of energy.